I've written out the general equation for a quadratic function, so that's f of x equals ax squared plus bx plus c. We've got access to the coefficients here, a, b and c. Now we've seen this in a previous video. And what we're interested in is looking at the roots of this quadratic, so that's where it crosses the x-axis, and there's going to be three different conditions that we're interested in. So first of all, we notice in this case here that this graph here doesn't actually cross the real axis at all. So that means in this condition here there are no real roots. Now if we were to move the graph down a bit until eventually it crosses the axis, you'll see here in this condition it crosses the axis at two different points. So that means we're going to have two real and unequal roots. Now there is a third condition, and that is when the graph actually sits on the x-axis. So if I change this value here to 0.15, you'll see it sits on the axis. Now in this condition, it looks like we have only one root, but in fact there are actually two roots here, but the roots are equal. So what we say is the roots are real and equal. So those are the three conditions that we're interested in. Now there is a way of determining whether your polynomial falls into one of each of those three, and that's by using something called the discriminant. So let's go ahead and we'll look at this discriminant. So this is the quadratic formula, and it tells us the roots of a quadratic function given the coefficients a, b and c. Now this little section of it here, b squared minus 4ac, is a very useful term, and it's given its own special name, and it's called the discriminant. Now when the value for b squared minus 4ac is greater than 0, then the roots are real and they're unequal. If b squared minus 4ac equals 0, then the roots are real and they're equal. If b squared minus 4ac is less than 0, then the roots are non-real. So those are the three conditions that we've seen just a second ago. So in this first condition here, we have the function crossing the x-axis at 2 points. So we've got 2 points here, the roots are real and they're unequal. In the second condition here, b squared minus 4ac equals 0, that meant that we had the repeated roots, so the function sat just on the x-axis. And in the third one here, there were no real roots, so the function sat above the x-axis, so it didn't cross over the x-axis. And we can tell what our quadratic function is going to be like depending on these values here. That's the value of the discriminant. So let's look at a couple of these in the graphical calculator. So we've added the value of the discriminant at the bottom here, so that's b squared minus 4ac, and you'll see that whenever we move the function up and down, whenever it's above the x-axis, that is, it doesn't cross, so there are no real roots. You can see the discriminant is a value of -7, so it's a negative value. So as long as it's above the axis here, that value of the discriminant is negative. But whenever the function crosses the axis, you see the discriminant becomes a positive value. And whenever the value it actually sits on the axis, you'll see that the discriminant is a value of 0, exactly as we've just seen. So thank you for listening. I'll get you on the next video. Goodbye.